Welcome to my channel. My channel is called Shuttle, and Shuttle stands for Sharpening Your Habits to Understand, Time, Test, and to Learn Entrance. In this chapter, we are going to learn about mechanical properties. We'll learn about mechanical properties of both solids as well as liquids. We will explore different properties like plasticity, elasticity, and rigidity for different substances. We'll introduce you to different types of solids like elastic, plastic, and rigid, and we will investigate its elastic behavior. We will study about different types of stress and strain and their interconnections, and learn about the law which shows the proportionality between stress and strain. We will investigate different important points on the stress-strain curve and also show three kinds of solids can be further subdivided into elastic, plastic, and rigid in respect to how they react to the deforming force. If it is quickly restoring its configuration after the deforming force, it is elastic. If it is not able to restore its original configuration, then it's plastic. And if I am not able to change the original configuration, then it is rigid. A deforming force is a force that changes the configuration, the length, volume, or the shape of the body. And the property by which a body regains its original configuration after the deforming force has been removed, that property is called as elasticity. Stress is divided into longitudinal, volumetric, and shearing stress. If the deforming force is normal to the surface area, it's a longitudinal stress. If the deforming force is radial, then it's volumetric stress. And if the deforming force is parallel, then it's called as shearing stress. In general, stress is my restoring force per unit area. So when we're talking about stress, stress is considered as a scalar because the direction is already prefixed. You clearly see in this case that my restoring force is acting opposite to my applied force, and stress is this restoring force per unit area. So it is force per unit area, so it is having the same SI unit of pressure, the unit of pressure Newton per meter square, and its SI unit is pascals. In longitudinal stress, my force applied is normal to the cross-sectional area. So when my force applied is normal to the cross-sectional area, the strain is going to be longitudinal. So if it increases the length, then it is tensile stress. And if it decreases, when my longitudinal stress is producing an increase in the length, that is called as, when my longitudinal force is producing an increase in the length, that is called as tensile stress. And when my longitudinal stress is producing a decrease in length, that is called as compressive stress. In the case of a volumetric stress, my pressure is acting from all directions. Therefore, it causes a decrease in volume. Therefore, in case of volumetric stress, there is a decrease in volume due to the radial pressure that is acting on all directions. Let me define what is meant by an elastic limit. So it is the upper limit of the deforming force up to which, if I remove this deforming force, the body will regain its original form completely. So only up till this point the body will regain its original form, otherwise it will get permanently deformed. So that is called compressibility of a material is the reciprocal of bulk modulus. So we are dealing with three kinds of modulus: Young's modulus, we are dealing with bulk modulus, and we are dealing with shear modulus. Of this, Young's modulus and the rigidity modulus are applicable only for solid. We talked about stress and strain. We talked to understand what is stress. We just introduced stress as force per unit area, and then we introduced you to the first kind of stress called as a longitudinal stress, in which we saw that